Well, hello there, and welcome to another episode of the making of Pokemon Gemini. It's been a while, hasn't it? Yeah, life is kind of crazy. Haven't really had time to work on this, and honestly, the main thing that's been stopping me from continuing the development of this is the time it would take to sit down, record one of these kind of development log videos, edit it all so it looks nice and polished like the other episodes. All of that takes time, and I just haven't had that much time lately. A lot of job stuff going on, but that's beside the point. Um, and I mention all of this because you'll notice this episode is not edited. There's no little progress bar on the top that separates the sections. Unfortunately, I know it's nice to be able to jump to the sections you're interested in. I just don't have time to add that. There's no intro. This is going to be completely raw and unedited because that's all I have time to do. It's officially the middle of the night right now, and I'm just going to get this development done and just happen to do it on camera for you guys. I hope I'm not too boring. I hope it's not too boring without any flashiness, but anyway, so in the past, I feel like it's been almost a year since the last episode. There has been very minor updates to the development of Pokemon Gemini. Most of it has been planning, so I've done, if we come into here, in the documentation, I've gotten some calcs, I've added some Fakemon ideas, etc., etc. But I've also gotten these. Nope, sorry. I've also gotten these. So it's a little hard to see, but basically, these are Fakemon, fake Pokemon. Uh, Let me see if I can change the view a little bit, make it easier for you. These are already large, extra large icons. There we go. So you can see that we've got some, you know, we've got shiny versions of some of these. Some of them don't have shiny versions, but that's okay. These are the legendaries. And you see we've got the front and the back sprites. So all of these are ready to be used in battle. Now the battle system, the main menu system has been completed. You saw that in the first episode, but the actual battling system hasn't even been touched yet. So this is for the future. But the point is, they're here when we need them. So when we get to programming the battle system, we will have at least these to start incorporating into the game. And all of these came thanks to Zach Foster, whose Reddit name, if you want to go contact him, is Fosters313 with a Z. And this guy has been great. He's just been pouring in designs faster than I can even look at them, and it's amazing. So the theme that I've come up with for the game is New Zealand. Sort of. Very loosely based on New Zealand, because every Pokemon game is loosely based on a real-world location. So Kanto was based on, I want to say, I think there was a region called Kanto in Japan, and they just named it after that. Johto was also based on a region of Japan. Unova was based on New York, and Kalos was based on France. Alola was obviously based on Hawaii. So every generation of Pokemon is based on a real region. I had the story and setting in mind for Gemini long before I thought about regions or real world analogs. So what I had to do was kind of retrofit it. I had to find a real world location that matched the geography that I wanted. And I came up with New Zealand because in Gemini there are two main islands with a small bridge between them. And New Zealand is made up of two large islands, and they're even called, I believe, like North Island and South Island. So it's perfect. And once I had that in mind, I realized that a lot of the kind of art style and Pokemon in some way should relate to New Zealand. Not necessarily all of them, and if you're from New Zealand, I hope you don't take offense because a lot of it's going to be totally off. This is mostly just a new region, completely fictional, but with some inspiration from New Zealand. So, for instance, we've got a tuatara here because tuataras are native to New Zealand. So it's based on a tuatara and the third eye of a tuatara, which is why it's psychic type, of course. We've got Ruatique and Ruatifact, which is based on an old Maori legend regarding tikis, and hence tikis. And then we've got Maotide and Wetitide. I just noticed that Zach added this here. This was the previous version of Maotide that I thought looked too much like a crab, so he altered it to be like this. So this is based kind of on the Weta, which is a bug native to New Zealand, and this is a Weta larva. I guess he just didn't want to let go. And yeah, so I'm not going to go through all of them, but the point is that a lot of these are based on New Zealand, and some of them are not. Pretty straightforward. Charip and Grimoire. These guys are going to be the ones that you find in graveyards, sort of like a static Pokemon, and their ability lets you revive your Pokemon when they faint. Basically, if they're in your party and another Pokemon that you have faints, then it'll give you the option to just kill off this guy and revive your other Pokemon to full health, or maybe half health. We'll see how that calibration goes, but yeah, so it's basically Grim Reaper. So you get that skull and the darkness and kind of the hood and all of that fun stuff. Anyway, again, don't want to get too much into the details of this. This will be used later on once we get to battling system, which we are not doing today. And then another thing I have is the overworld sprites for the trainers, for the actual players and NPCs and stuff. This is just a sprite sheet from opengameart.org by a user called Corey Archer, and it's just a sprite sheet of just basic Pokemon style JRPG NPCs with animations and everything. So that's great, and it's open. It's free to use for anyone as long as he gets credit and gets to see the final product, which he will once the final product is done. And I've already imported them into the game here. Now this is the old Pokemon that I was using as kind of a demonstration. This one is not available to be used in an actual product. This is copyrighted to someone else. So I'm leaving it in for now, just until I actually get to the battle system. But once I do, I'm going to remove it and it won't be part of the game. So yeah. All right, so all that's done. Let's get to programming. So today, as you can see by the title of this video, is moving day. And what does that mean? Well, let's start this up and show you kind of what was already there, in case you've forgotten from the last episodes, which is very likely. It's taking a little while to compile, I guess just because I haven't run it in a while. Maybe some of the cache files are, gone. But any second now. There it is. Okay, so what we had was this region detection system. So when I move the mouse around, you see region 0, and region 3, and 0, and 3. I think I only had region 0 and 3. Oh, I've also, by the way, since the last episode, added the official Pokemon black and white font to the game, so it looks nicer. I actually really like that font for my own use too, but anyway. But yeah, so what we had was this region detection that could detect when the mouse moved between different regions and pop up a little box to show you that. And the actual region painting was done with tiles so that we could just paint in the areas of the level that are the boundaries between different regions without having to, kind of hard code all the coordinates. This makes it easy. So the first thing we're going to need, though, is a character, a player. And that's because, obviously, in the game, you're not just going to be moving your mouse around between the regions. You want a player that can move, right? So I'm going to create a object group here, just to keep everything organized, called NPCs. Or I guess technically NPCs is not the right name for a playable character. So I'm just going to rename this. I'm going to rename this, I said. I don't know. People. Let's call it people. Or you know what? Let's stick to the same naming convention that we used here, right? Naming conventions are an important part of programming to keep everything organized and readable, so let's stick with that. So this was called overworld, and then characters, and then trainers. So this is for trainers in the overworld, which includes NPCs and the player, but we're going to start with the player. So what was the naming convention I used? Just, okay, player. So the first thing is we have to decide what the player's sprite is going to be. Now we have these 4 sprites, and the reason there's 4 different sprites instead of 1 animated sprite is because each of these is animated. So there's different ways you can handle having multiple animations for one object. You can have them all in one animation and then just kind of have some code determine which frames to play and sort of where the looping points are, the in and out. But in this case, I just went with the way that I usually do things, which is I split each animation up into its own sprite, and then we'll have code that determines which sprite to use. So to start off with, it doesn't matter which sprite we start with, but I'm just going to go with, overworld, characters, trainers. I'm going to go with facing up, because usually in the games you start facing up, so why not? Doesn't really matter. And I'm going to give him some code when he starts. Actually, I want to also make him, where did I have him? Managers? No. Parents, there you go. I want to parent him, or give him callable as a parent. So he's a child of callable, which if you watch the other episodes, you know that just basically means that I can give him methods that other objects can call for him to do. I can't think of anything right now that I would need for that, but I feel like in the future he's going to need some methods like that. So I'm just going to call him, I'm just going to set his parent to callable right now. And then I just want to double check. Like I said, it's been a while since I've opened up this code. So if we look at this, this is callable, and it pretty much just sets up the methods and sets what their user-defined event indexes are. So play music is event 0, fade into music is 1, play sound effects is 2, etc. In this case, we don't have any yet, so I don't think we need any other setup. So we do, however, need to call the inherited event first so that all of the callable method code can run for it. But now we can work on the actual code. So in in the Pokemon games, the player moves on a sort of grid. And in this case, these sprites are 16 by 16, so we'll make it a 16 by 16 grid, which I believe these are all 16 by 16, yeah. So perfect. So he moves on a 16 by 16 grid, which means if you tap an arrow key, you want him to move a full 16 pixels, not a small bit, right? And the other thing is that while moving that distance, the animation should play and it should smoothly move. So even though a single tap will push it over by 16 pixels, it's not going to do it instantly. It's going to go like 2 pixels and then 2 pixels and then 2 pixels, right? So we need to set all that up. So what I'm going to do is I'm going to give it a couple of variables. Go to X and go to Y, which start off as the X and Y. Set the player. Now, when we change go to X and go to Y, it's going to trigger some code and tell it to start moving towards those coordinates that we've set. So for instance, if later we said go to X plus equals 16, well, it's going to then have to move 16 pixels over to the right. If we did go to x minus equals 16, it would move 16 pixels to the left. And you could do the same with y, right? Of course, right now it doesn't actually do that. So now we can run some code. Oh, and then the other thing we have to do is, because these are animated sprites, we want to do sprite, image speed is 0, so that it's not animated by default, because when you're not moving, you don't want it animated. And then image index equals 0 as well. So this is just to start at the first frame and not playing the animation by default, right? So now, every step, which is every frame of the game, or 30 times a second, it's actually going to be pretty simple. The first thing that we want to do is the actual movement, and then we can work on the input later, so the actual keyboard presses. So all we have to do is check if we're, how do I describe it? So we have to check if we're not at the coordinates that are stored in the goTo x and goTo y, and if we're not, we should move towards them, right? But if we are at those coordinates, we don't have to do anything, but we also want to stop any animation that's playing, because the animation should only play while you're walking, right? So that's actually pretty simple. So the first thing we do is we have if x equals goTo x and y equals goTo y. So if our current x and y coordinate equals the goal, the go to x and go to y coordinates, then we're exactly where we should be, and we don't have to do anything, right? We just want to stop the animation. So image index equals 0, image speed equals 0. And the reason we set image index to 0 here is just because if while you're walking, you're sort of in the middle of an animation, like with your foot sticking out in front of you, and you reach the goal, we don't want your foot to stay out in front of you, right? We want to reset back to feet on the ground, which is the first frame of all these animations. So we do that. So that's pretty simple. However, if we are not, at our goal, then we need to start moving. So the thing about Pokemon and the way Pokemon's movement works is it's not only attached to a grid, but you can only move in the 4 cardinal directions, right? You can't move diagonally. Oh, I just realized my mic was somewhere else. I hope you still heard all that. Anyway, you can't move diagonally, right? So we have to decide which directions take precedence over which other directions. So should it be more important to move left and right than up or down? Or should it be more important to move up or down than left and right? Honestly, I don't think it really matters. We just have to pick one. So I'm going to go with left and right is the main thing. So if your goal is not at the current position and it's, and it's off somewhere that's different in the x and y, you're going to move to its x coordinate before you start moving to its y coordinate, right? So first, if the x coordinate is different, if the x does not equal goTo x, then we want to do x plus equals, and actually here's where we want to create some speed variables. Instead of hard coding the speed, this way we can change it later easily. So I can't use speed because that's built into GameMaker, and GameMaker will try to handle the movement for me, which I don't want it to do. So instead, we'll call it SPD for speed. And we'll pick a speed that seems reasonable. I think 2 would be too slow. 16 obviously would just jump to the next grid space, which is too fast. So let's go with 4. So it'll take 4 frames to get to the next grid space. And there are 4 frames in each animation, so I think that might just be perfect. We'll see what it looks like and modify it later. That's why we're putting it in a variable, so we can calibrate it later. But we want to take the speed, and then we want to multiply it by the sign of go to x minus x. So what I'm doing here is go to X is our goal, right? And X is our current position. So if we subtract go to X minus X, if go to X is larger, it will be positive and the sign will be +1. If go to X is smaller, then this will be negative and the sign will be -1. And so by using this, we're taking the speed and we're changing the direction that you're moving in based on which direction you have to go to get to the goal, right? So yeah, that's all that is. And then before we do that though, we want to make sure we adjust the animation. So I think what I'm actually going to do here is create a little variable called direction. Well, I can't use direction because that's another built-in one, but dir. And we'll set that equal to go to the sign of go to X minus X. And then we'll plug that variable in here. And the reason I'm doing this is because I'm going to use that again, and instead of having to recalculate it every time, we'll just calculate it once and store it and then use it. So now what we do is if direction is greater than 0, so you're going to the right, because right is positive X. If direction equals 0, sprite index equals, I guess, spur player right. Else if direction is less than 0, so you're going to the left, sprite index equals spur player left. So this sets the animation to either the facing right or facing left. Now I could have used just one sprite for that and mirrored it with code, but I didn't feel like doing that really because we needed separate sprites for up and down because it shows the front and back of the player. So since I'm already doing that for up and down, I might as well just do the same for left and right, I think. And then we do the actual movement. Okay, and now we do the same thing for the Y pretty much. So I'm going to copy and paste this and just change all the X's to Y's. So we see whether we're going up or down. If we're going down, because in 2D computer graphics, the y-axis is down for historical reasons. It's kind of annoying because in math, the y-axis is positive when you go up. But somebody, somewhere in the history of computing decided that the top left corner should be 0, 0, and that down should be positive. I don't know. It's fixed when you get into 3D. When you get into 3D programming, then up is positive y, but in 2D programming, it's down is positive y. Either way, the math is still the same, but we just have to know that if the direction is positive, then we are moving down, so we should use the down sprite. And if it is negative, we are moving up, so we use the up sprite, and we change the y coordinate, not the x. So now the only thing left to do is just to make sure we set the image speed a half a frame per, or a half an animation frame per frame of the game, or rather what's called a half a frame per step, is generally a good idea. I might need to make it slower or faster. Again, these will be adjustable. But I think this is pretty much it. If we do this, then anytime we change go to X or go to Y, it should animate moving towards that spot on the X-axis first, then the Y-axis, and then stop. And it should look perfectly fine. So now all we have to do is get some input. In other words, we have to, so let's comment this and just say actual movement. But now we need some input so that the player can press keys. So keyboard input. Now in GameMaker there are events for this, but I like to do input in the step event just because I'm more code oriented than I am event oriented. It's preference. So what we have to do, Well, one thing is, actually, we need to incorporate this into our code because we don't want to keep changing the position while you're walking to the new grid space, right? So let's say I'm here and I want to move here. If I hold down the right arrow key and it checks it, and it's going to say, okay, add 16 to the go to X, right? So that you go this way. But then you won't get to there for a few more frames, a few more steps. So in that time, you don't want it to keep adding 16, otherwise it'll just constantly move ahead of you, and you'll never reach it. So we only want to change the goal coordinates if you're at the previous goal, right? So that's here. So we will check if keyboard check. In other words, if you are, it's checking if you're pressing a key. So should we use WASD or should we use arrow keys? Now we could do later on, we could implement a key binding system, but for now, we're going to hard code the keys just to make it easier. So I think virtual key left, which is the arrow key for left, is there. So if you're pressing left, yes. So if you're pressing left, then go to X should be, you should subtract 16. So it goes this way by 16 pixels, right? Else if keyboard check VK right, then go to X plus equals 16, because if you're going right, then it's that way, right? It's plus 16 pixels. And then we just do else if keyboard check up. This time we're going to work on the Y. So go to Y minus equals 16, because remember in 2D graphics, up is negative Y. And then else if keyboard check VK down, then go to Y plus equals 16 because it's positive Y. And then the last thing I'm going to do is add an else here and put the animation stuff, the animation stopping code in an else. So this way, if you're holding down the keys, the animation won't stop every time you reach a new tile. It'll just continue on until you let go of the key and it's reached its destination, right? So I think that is fine. So this should work. So if we stick the player into the demo room, let's grab our overworld character trainer player and put him there. That is a problem. Right, so what's happening here is that I've centered these sprites' origins, so they're anchor points, to the center of the image. And so when I place him down here, it's trying to anchor him to the grid space, which is actually 8 pixels off. I don't think I need to center these, though, because I'm not going to be doing any kind of rotation on it. They're just changing it's just changing the actual sprite for each rotation rather than like doing any kind of rotation calculations. So it shouldn't need to be centered. So I should be able to do that. And see, now he's directly in the middle of a grid space. Okay, so let's see how this works. So if I play this, I should be able to use the arrow keys to move the player around, right? So, okay. I feel like it's really fast, but it works, right? You can see the animation stops when I stop. He's moving on a grid space. If I just tap it, he just moves the full grid space. And the sprites are changing to face the right direction. So it all works. Now we just have to play with the speed a little bit. So 4 is too fast, so let's go with 2. And then the animation was playing way too fast. It just looked like he was jiggling. So let's bring it down to 1/10 the speed for the animation. 0.05 frames per step rather than 0.5. So half the speed and 1/10 the animation. I'm not really sure how I feel about that speed, but the animation is too slow. Only slightly, though. So let's bring the animation speed up to 0.1, which is twice as fast as it just was, but still 1/5 as fast as the original speed. And I know this might seem a little finicky, but a lot of game development, game design, really, is finicky. It's just getting numbers to look right and feel right. And we'll fix that region system in a second, but maybe just a little too slow. I think the speed is okay. Now I don't want to use, so I went from speed 4 to speed 2. I don't want to use a speed of 3 because it's going to be moving in 16 pixel blocks, and 16 is not divisible by 3, which means you're going to overshoot the goal and it's going to cause problems. So I want to make sure I use speeds that are divisible by 16 or that divide into 16. But I do want to, I think, just one more time to double that animation speed. So we'll bring the animation up to 0.2, which is still less than the 0.5 it was originally. And hopefully this will look a lot better, or a little better, I guess. There you go. I like that. I like that. And I mean, it does feel a little slow, but at the same time, in the Pokemon games, it is slow until you get your running shoes and your bicycle. So, you know what? I think that's fine. So the next thing that I'm going to do is update the region manager. So right now, the region manager, it's, where do I actually set the animation? Okay. So right here, it's grabbing the X and Y the X and Y coordinates to check the region of from the mouse. But we don't want that anymore because now we actually have a player and we want to know what region the player is in, not the mouse. The mouse doesn't matter anymore. So the way this is set up, it's just grabbing a position to check every frame. So it actually should be a really simple fix. So let's comment that out for a second and we'll delete it if it works, or if our changes work. And we just set var xx equals player x, yy equals player y. That should literally be all we need to do. So if we walk up, we're in region 0, then region 3. Region 0, region 3. But it did jump when I first crossed that threshold. So if you look in the room, you'll see that the region threshold is two regions here. So what happened was I crossed over, and originally, apparently, I wasn't in any region. So when I walked up here, I went from no region to region 3, and then I made the next step and went to region 0. So we need to give him a sort of default region. And I'm not sure what the best way to do that is. Because on the one hand, I could just hard code all the region data, right? I could hard code all the region data here. For the default region. But I think the better way to do this, because this is a demo and the actual regions are going to change, the maps are going to change later, I don't have to go back and change any code. So I think what I'm going to do is just, if the player starts here, am I on the right region? Or the right layer? Yes, that's the only layer we have. Good. I'm going to pick region 3, because this is region 3, and just drop a tile there. So when the game starts, you will already be on a tile that sets you into region 3. So if I do it this way, it should immediately pop up telling me I'm in region 3 when it starts, which it does, good. And now that I'm in region 3, when I walk up, it'll just say I'm in region 0, and it won't flash between 3 and 0 because I'm already in region 3. So that is good, that is fine. And what this means for future development is that anywhere that you can start a map needs a region tile on that space. So basically in front of every door that you can walk out of, and in front of every place you can fly to, and obviously on the borders of regions, but that doesn't matter so much because that was already intended. So it's just anywhere that you can walk out of a door into, and anywhere that you can fly to, it needs a they need a region tile on them to initialize the region before so you don't have to go out into the borders and it knows what region you're in. So that is not a big deal, and it works, as you can see. So now we have a player, he can move, his animations work, and region detection is now based on the player's position rather than the mouse, which is much more like the game. So everything here is good. The last thing I want to do is try to incorporate the running shoes concept. So with the running shoes in the game, you can move faster by holding B. So that should be pretty simple because we have this speed variable here, and we are actually doing the motion here by multiplying the direction times the speed. So I can think of a messy but mathematical way to do this, or we can do it the cleaner way that is less mathematical and more code. So I'm going to do it the cleaner way. So basically, what I'm going to do is I'm going to have a running modifier, which is starts out as 0, or sorry, starts out as 1, and then if keyboard check, so B is usually the button used for running modifier, but actually I think because this is on a keyboard layout, I think shift might actually be a better fit, just more convenient to press when you want to run. So if you're pressing shift, running modifier equals 2. And so now all we have to do is multiply these by running modifier for the x and the y. So if you're not pressing shift, the running modifier will just be 1, and 1 times speed times dir is the same as what we had before, speed times dir, right? So it won't change. But if you are pressing shift, it'll be 2, so it'll double the speed that you move at. And so running shoes, holding shift should be fine. So if I walk normally, I walk at this speed, which is the same speed. But if I hold shift, I move much faster. However, it is a little awkward to have the, well, I was going to, what was that? Oh, okay. So with that little shake there, so that is a glitch that is caused by the fact that it's checking for if you're holding shift every frame of the game, even if you're in the middle of moving to a new place, right? So what's happening is I'm moving at a speed of 2, and it's a 16 pixel gap between blocks, or between grid spaces. So I might be able to get to, let's say 14 pixels, right? If I get to 14 pixels and then I press shift, well, now I'm going to be moving at a speed of 4, so 14 plus 4 is 18, which is 2 beyond the 16. So it'll overshoot. So now it'll move backwards by 4, but 18 minus 4 is 14, which is 2 before the 16, and it'll just go back and forth. So that's what's causing that. So to fix that, we need to decide whether you're running only when you first start moving, not in the middle of a sort of animated movement, right? I don't want to call it a step because it's multiple steps, but you know. So what I can do is I'm going to put the running modifier in the create event and just make it an instance property so that it persists over multiple ticks. Because if I do var running modifier here, then it's only going to, that variable is only going to exist for one tick, one step, one frame of the game. And then the next frame it'll be reset and disappear. But we want to keep it over multiple steps so that we can set it only when you first start moving, and then it'll retain that value even if you let go of the key, right? So if you press shift and then move, and then you let go of shift, the running modifier shouldn't change until you're done moving. So if, so inside this statement where we're checking if you're at the goal, only then do we check if you're pressing shift. And then set the running modifier to 2. And if you're not pressing shift once you've reached the goal, then it should reset the running modifier back to 1. So in this way, we're only changing the running modifier depending on whether you're pressing shift or not while you're at the goal. So that way you can't change it in the middle. So one full 16 block travel will always be at the same speed for each step, right? So now if I hold this, I can shift and speed up, shift and speed up, shift and speed up, shift and speed up, but I can't start moving and then press shift, right? So we don't get the jiggles anymore. So there you go. So that's pretty cool. So the last thing to test is what happens if I press more than one button, one arrow key at a time. So this is, if I press up and right, doesn't matter what order I press them in, right takes precedence. If I press down and right, same thing. Left and down, left takes precedence. And then up and left, left takes precedence, which is what we said the x-axis was going to take precedence. Now if we press down and up takes precedence every time. And if we press left and right, seems left takes precedence. But that's fine, right? As long as one takes precedence and it doesn't start jiggling back and forth, it's perfectly fine. I mean, it's starting to look a little like Twitch Plays Pokemon, but that's just from me pressing keys. But yeah, so region mapping works, player animations work, player movement works. We're all good. I was going to also start incorporating collision detection and terrain in this episode, but it's already 43 minutes in, which is a lot longer than I thought it would take. And again, this is unedited. So yes, everything today, moving day, is done. The player can now move and run and walk in all 4 cardinal directions, aligned to grid spaces, with full animations and region detection. We are getting, well, we're not getting closer to the final game, at least not at any reasonable speed, but we are making progress. So next time, I'll probably be working on collision detection, like I said, and terrain mapping, which is kind of the same thing, and you'll understand once you see that episode. But for now, I'm just glad to have finally gotten back to development, and a huge thank you. Yep. A huge thank you to Zach Forrester for all of these lovely Pokemon. My goal in an ideal world is to have around 150 brand new fake Pokemon, so that if by chance I release this and Nintendo does what they did to Pokemon Uranium and says, you can't do this, cease and desist, because you are using our copyright, I can take it down, retheme a few things, take a couple of months to retheme some things, and re-upload it as a different game with all the same mechanics and all of the same graphics and all of the same everything, and just change a few words around. And that should fix it, because then it won't use any Nintendo copyright. They don't have any kind of patent on monster catching or battling games. There's plenty of those out there in the world. So yeah, if they want me to cease and desist with their intellectual property, I will. And so to make that easier on me, I'm going to start, from the beginning. I want this game to have as many fake Pokemon as possible and not include any real Pokemon, so that I can just retheme some things and keep all the same creatures and have it work out. So these are a great start. Thanks again to Zach Forrester. Thank you all for watching, if you are. Yeah, so until next time, keep developing, keep moving,